all know that solids change to liquids and liquids to gases when they heat up. The reverse happens when they cool down. But what is temperature anyway? What else changes because of temperature? And what else affects how matter behaves? Today we are going to review 3 science terms that are very important to understanding matter and how it behaves. These terms are volume, temperature, and pressure. You have definitely heard the term volume before, probably in math class when you were asked to find the volume of a rectangular solid using the formula length times width times height. Volume isn't just this formula though. The term volume describes how much space something takes up. Sometimes you can use the formula to find the volume of something, but more often something has irregular sides, making it necessary to determine its volume another way. Remember how volume is the amount of space that something takes up? Well, we can find that amount of space by doing something called the water displacement method. Any given amount of space can be occupied by only one thing. Like when you get into a bathtub, the water level in the tub rises, and the more of yourself you submerge in the tub, the more the water rises. Your body is pushing the water out of the way, making the tub appear fuller than it actually is. In science, we can use the same method to find volume, but we just don't use a bathtub. We use something called a graduated cylinder, which is basically a tube with markings labeling the measurements. And by filling the cylinder part of the way up with water, we can observe how much the water level rises when we add our object. The amount the water rises is the volume of our object. We measure volume using variations on 2 main units, the liter, abbreviated with a capital L, and meters cubed, or cubic meters, abbreviated m to the power of 3. We typically use the unit liters and milliliters, etc., to measure liquids, gases, and irregular solids, so things you need water displacement for. And we use meters cubed and centimeters cubed and so on to measure the volume of easier to measure shapes like boxes and cylinders, etc. Now on to temperature. This is another term that you have definitely heard before. You even already know a unit that we measure it in. In everyday life, we use temperature to describe how hot or how cold something is, but this is not the full definition. What temperature actually tells us is how fast the particles in a substance are moving. Temperature is a measure of how fast the particles in a substance are moving, otherwise known as a measure of the average kinetic energy of the particles. The faster the particles are moving, the higher that kinetic energy, the hotter the substance. In the United States, we typically use degrees Fahrenheit to measure temperature, but in science, we actually use degrees Celsius or kelvins. We use Celsius instead of Fahrenheit because Celsius and kelvins have the same sized units. If you increase by 1 degree Celsius, you also increase by 1 Kelvin. But why kelvins? Kelvins are a measure of how much kinetic energy, energy of motion, is in a substance. As such, there is no negative kelvins. 0 kelvins means that all of the particles aren't moving at all. This is so incredibly cold that scientists have never actually cooled something down to that. Last but not least, we have pressure. The scientific definition of pressure is the amount of force applied over a given area. This means that you can actually increase the pressure on an object by either applying more force or by decreasing the area over which that force is applied. This is why when you poke a balloon with your finger, the balloon is perfectly fine. But if you poke that balloon with a needle, it pops. The tip of the needle has a much smaller surface area than the tip of your finger. So all of that force is concentrated over a much smaller area, driving that pressure to be much, much higher. In science, we often talk about air pressure, the amount of pressure the air is applying to something. When we imagine the pressure in the needle balloon scenario, it's pretty easy to visualize. But thinking about air pressure is harder. Air pressure is the result of air particles colliding with each other and objects like the inside of a balloon, and actually the outside of it too. The number of collisions between the air particles and how hard they are colliding create that pressure. There are many units of pressure. The three big ones are the Pascal, which is a Newton per meter squared, the atmosphere, abbreviated ATM, which is used for measuring atmospheric pressure, and millimeters of mercury, mmHg. Learning vocabulary in science is super important. These vocabulary terms allow us to communicate with other scientists so that we all have the same words to describe the same things. So to summarize the words that we learned about today, we learned about volume, which is the amount of three-dimensional space that things take up, temperature, which is the average kinetic energy of particles in a substance, like how fast are they moving, and finally pressure, which is force per unit area. And that's it. I hope this was helpful and that you have learned three terms that you can practice and apply.